Yeah, sending live. Hello everyone. Hope you are all doing well. Welcome to today's webinar on the topic of AI enhanced threat detection led by our trainer and cybersecurity analyst Jui. Whether you are a cybersecurity pro, a business owner, or simply concerned about safeguarding your personal info, this session is packed with insights to keep you a step ahead of artificial intelligence revolution in cybersecurity. Throughout this webinar, we'll dive into the best practice of security, shedding lights on significance in today's rapidly evolving threat landscape. So without any further ado, I request Juhi to kindly take over. Over to you, Juhi.
Good afternoon, everyone. Thank you, Pratik, for the introduction. And I am the presenter for today's webinar. And we can see how AI is expanding its reach and, embedding itself across nearly every possible domain. And so far, AI has been managed to mark its place, as I said, in every possible domain. So what we are going to see is how AI is making the changes, or you can say shifting the gears in threat intelligence and threat detection, and how it is evolving the whole domain of threat detection. Okay, so what we're going to do is we would be beginning with the increasing complexity of cyber threats, threat detection, evolution of threat detection. Then we would be proceeding to see AI enhanced threat detection and look at some of the core techniques that are available in AI for threat detection. And finally, we would be moving towards seeing that post detection, what are the other things, how where AI can be helpful when it comes to doing certain processes in the threat detection uh, so the scenarios. And finally, we will be looking at some of the future trends that AI brings to the table for threat detection. Okay, so let's embark and begin. Uh, One of the reasons why threat intelligence and threat detection becomes so important as of now is increase in the volume of cybercrimes that we are seeing. So if you look at the statistics starting from 2023 to 2024, and now as we are already ending towards a year and going towards 2025, so far, like if you see phishing, then there has been 100% increase in the number of cybercrimes when it comes to phishing. There has been a exponential increase in DDoS attacks, like it's about 35%. Even the ransomware, if you see the industry globally, then up till now it was 7%, but now it has increased to 10%. Threats has come to around 75% increase. And if you look at the future predictions, then it is projected that by 2025, the cost of cybercrimes could go to around $1.2 trillion. So that itself shows how important it is to work or to be proactive for threat detection, and it's more as a need of the hour instead of just a market trend. Okay, then sophistication of threats, as in these days, like thanks to the new evolving technologies, you can see that the because of there are so many attacks that where AI is being used, then malwares are now evolving and they are becoming polymorphic malwares where they can easily evade detection, and um, even blockchains are being exploited. So there is a sophistication of how the attacks are being performed. Even if you look at certain cases like Stuxnet, which was an old attack that happened years ago around 2010 2012. Now it is evolved, and some of those older attacks are again being evolved and used by attackers in new ways. So there is a sophistication of threats. Then information stealers, many of these attackers, what they do, they have started like increasing the use of phishing, increasing the use of click checking and all, for harvesting information, stealing user credentials, and then selling on the darknet. That's also an increasing trend that we see, giving rise to quantum computing. It gives a threat to encryption when it comes to securing the data, because most of the encryption methods, for instance, RSA, ECC, they are heavily based on mathematical computations and computer quantum computing algorithms like uh, sorry, I forgot the algorithm name, but there are algorithms in quantum computing which, they can easily evade these encryption algorithms, and they can just easily compute it. So exposing public keys and all becomes very easy. And then there are these attackers who just keep on collecting the encrypted content, and they are waiting for quantum computing to evolve. So the day it evolves completely and it becomes accessible, they would be using the quantum computing methods to decrypt all the data that they have collected so far, right? So that's something like harvest now, decrypt later method that they use. Then regulatory changes day by day as the laws are being changed. It becomes difficult for the companies to keep up to all the requirements that these compliances are asking them to make. Also, a lot of resources are more used and occupied in adapting to the regulatory changes or adapting to these regulatories, rather than looking at the security posture of the organization. So these are the some of the things that comes as an issue when you talk about regulatory changes. And then Trojan, ransomware, remote access Trojan, persistent threats. All these things are also evolving, and they are becoming more and more uh, some, and that is what shows why threat intelligence or threat detection becomes significantly very important for cybersecurity professionals to work on. Okay. Going back a bit, if you want to know like what exactly is threat detection, okay, then threat detection is a particular uh, part of the cybersecurity domain or the cybersecurity industry, where the focus is on identifying the threats before they can cause any harm to the organization. So you can say it's kind of a proactive mechanism where we, as a security professional, want to identify threats before they can be converted in, or before they convert themselves into attacks and they cause significant damage to the network, to the organizations. So, using techniques like monitoring, analyzing, okay, you detect malicious activities and detect vulnerabilities and try to mitigate all the threats and defend your organizations from um, significant threats and risks that the organization could be exposed to. Okay. So looking back at some history of threat detection, it somewhere began around 1970s with rule-based detection. Then it proceeded toward 1980s with signature-based detection. Then in 1980s to 1990s, we came upon heuristic-based detection. 1990s to 2000, we saw anomaly-based detection, and then finally it was the 2000s where we are seeing the AI-enhanced detection. Okay. So now coming to the main part, that what exactly will you say when you talk about AI in threat detection? So using artificial intelligence in threat detection would mean that we would be using techniques or methods of artificial intelligence or machine learning or um, predictive analytics for identifying and analyzing new threats, monitoring threats in real time, and then mitigating them. Okay, some of the features, or you can say some of the things that AI provides in threat detection is real-time analysis. That is, you'll be able to uh, identify threats in real time. Then advanced pattern recognition. Uh, Based on different algorithms that are available in machine learning or even in AI, that is neural networks and all, you can customize some particular algorithms. You can customize the parameters that you want to analyze, and that can help you for recognizing patterns in a much advanced form. Also, as it is AI ML, you can automate some threat responses, and your the machine learning model or your AI model itself would give respond, or it would itself would detect and respond to threats. Similarly, predictive analytics based on historical data or based on the large number of data that is available, some kind of predictions could be done. And there could also be a reduction in false positives through using AI. Some of the core techniques that comes in AI are machine learning. So when you machine learning, deep learning, natural language processing, anomaly detection, predictive analytics, behavior analysis, and real-time threat intelligence. So when you talk about machine learning, so algorithms or techniques of supervised learning, unsupervised learning, a reinforcement learning are some of the things that are some of the core techniques that are used for threat detection. For example, Windows Defender. It uses a supervised learning approach to block malware based on known signatures. Then you have the Google's DeepMind that allows or that uses reinforcement learning. So it improves the efficiency of data centers. Okay, it optimizes the cooling systems based on all the real-time feedback. Okay, so these are some examples. When it comes to deep learning, then CNN, uh, con- sorry, CNN, RNNs, and uh, could be used. For instance, you have this deep instinct that detects and prevents zero-day threats. Then security platforms like, for example, if you talk about Splunk, then it analyzes the security logs and identify patterns, okay, for potential threats. So that's how deep learning can be used. When it comes to natural language processing, then it's all about sentimental analysis, text analysis, where, for instance, you can see the Gmail spam filter, which uses natural language processing to identify and filter out phishing emails. Okay. Then sentimental analysis, you can use it for identifying, let's say, insider threats, where emotions, tone of communications can be used for identifying patterns of, let's say, a disgruntled employee or something. So that's how NLP can also come into picture. Then, when you say anomaly detection, then it's all about user behavior and deviation from behavior. Okay, so when you say anomaly detection, then in anomaly detection, there are statistical methods also, there are behavior methods also, where you try to identify deviations from the normal behavior. So, uh, let's say, for instance, you are using SNOT or another intrusion detection tool, and you are analyzing the network traffic. So, whatever traffic you are analyzing, if you find a major deviation from the norm, then that could indicate that it is a possibility of a threat, and that is how you can use anomaly detection. So the behavior analysis that I have written in the next point, that also is that's just a part of anomaly detection. where the more focus is on how user is performing all his activities, and we would be identifying user behavior and uh, try to create a user profile which shows what is the normal behavior of the user, and then try to identify deviations from the normal behavior depending on certain thresholds that are set. When you talk about predictive analytics, then most of the cases you use something like historical data, or and based on that you try to identify. For example, um, or a scoring data can also be used. For the example, HSBC, it uses a risk scoring system to detect fraud transactions. So that is something that can be done. Then real-time threat detection. So real-time threat detection, that would be identifying threats in real time, and somewhere try to avoid threats in real time. Okay, some of them have been able to avoid or have been able to detect zero day too, but it's a long way to go when you talk about zero-day attacks. So uh, I wouldn't be sharing much on that. Okay, but there have been some cases where it is possible. Okay, sorry. So how we can use AI in different fields for threat detection? So if you're talking only about cybersecurity, then for detection of malwares, for detection of phishing, like using machine learning algorithms to detect malware before they are being executed, or else to identify phishing attempts. There is a silence, a particular tool that uses this supervised and unsupervised learning methods to detect malwares. Okay, so there are already some applications that are available across different sectors. For instance, financial services, if you see, then in financial service you can use AI for identifying frauds and for identifying uh, anti-money laundering. For example, abhi jo, the example that I gave related to HSBC. So HSBC, it is using AI for identifying anti-money laundering attempts. So that is one of the use cases. Uh, then when you go to healthcare, so in healthcare you can again identify false medical bills, then false patterns for healthcare claims, then also to identify unauthorized access to patient data. For example, IBM Watson Healthcare is one of the live cases which keeps a watch on patient data and prevents security breaches from patient records. Also, there is a tool called as Optum, which uses AI to identify fraud patterns in medical claims, insurance claims. So you have use cases across the healthcare sector as well. Moving forward in retail, so you have this PayPal, which uses AI for identifying payment frauds. Then um, you can also use AI for monitoring the inventory levels to detect if there has been some kind of theft or there has been some kind of loss. So far, Walmart is using AI-powered cameras, actually, to monitor inventories and for detecting if there is some stock that is, or there has been some kind of theft of any items that are there in the Walmart store. So it is using AI powered cameras. Okay. And when you talk about public safety, so you can use AI for predicting certain kind of crimes or for surveillance. There is a tool called as the PRED tool that is used by law enforcement agencies for predicting crime hotspots and for identifying um, certain crimes that could happen. In fact, I believe it is the Los Angeles that has uh, reportedly confirmed that using AI has helped them to identify crime patterns, and they have been successful in avoiding certain incidents. So that can be used. Then for surveillance, there is a tool called as the Hikvision tool that is a surveillance tool, uses surveillance cameras for detecting and alerting unusual activities. So these are some of the cases when it comes to public safety. Going for industrial safety, um, if industrial safety where you are using huge equipments, you can prevent major accidents through trying to identify, failures in equipments. So General Electronics, it uses AI to monitor industrial equipment, and it tries to predict failures. So far they have been successful in doing that. Then for workplace safety also, preventing potential hazards, you can use AI. So there is this intense eye that uses uh, workplace cameras. What it does, it identifies, it analyzes the feed from the cameras, and then it alerts on any kind of potential hazard or any safety violation that is done by the people who are working over there. So it sends alert, and that helps in avoiding particular hazardous incident. Then going for national security, border security, so you can use AI for monitoring and detecting illegal activities, to like using the cameras, using sensors to detect border crossings. So the US Department of Homeland and Security is as of now using AI for that purpose. So that is one of the use cases. Also, you can try to identify and prevent terrorist activities. There is a uh, use case or a tool called as the Palantir that uses artificial intelligence. It analyzes large data sets, and it detects and tries to prevent terrorism activities, okay, terrorist threats. And finally, going to transportation. So, cases like fraudulent ticketing and vehicle security, all these things can be identified using AI. Like if there is someone who's selling, so committing a fraud in ticket sales, okay, for public transport, then AI can be used to, like the London Transport has been using it so far. And then vehicle security. So AI can be used for identifying security threats to vehicles, and yeah, Tesla has been using it. Tesla, it uses AI for detecting the security of vehicles. It tries to one of the use cases of how AI is being used by Tesla is they try to identify it, they try to detect hacking threats on the vehicles, and try to prevent any mishaps that could occur in the Tesla vehicles. Okay, so these were some of the live use cases that are available across different sectors, and where AI has been being used for threat detection. Okay, now how would actually threat intelligence or threat detection provide an edge over the traditional methods of detection? So, a few parameters if you could focus on. Uh, there is a parameter of detection methodology, then the speed of detection, adaptability, and false positives. So, when it comes to the detection methodology, while the traditional threat detection, it relies on predefined signatures and known threat patterns. Uh, Predefined signatures, you can consider it as previously how threats were being identified. Uh, However, the thread was identified, there would be a particular pattern to it, which you can call it as a signature. And then you would have a list of all those signatures, and based on that, you try to identify the thread patterns. When you talk about AI, as it uses machine learning, as it uses anomaly detection, it uses AI, it is a particular model that keeps on evolving. And as it keeps on evolving, the detection methodology becomes far more sophisticated, and that's how it provides cutting edge when you try to identify threats. In the speed of detection, traditional threat detection methods would comparatively be quite slower compared to AI ML techniques. When it comes to adaptability, so again, this point is connected to detection methodology. As the traditional threat detection is mostly using the predefined signatures and known threat patterns, most of these techniques, they are static. That means they have a particular list of signatures, or you can say a database of signatures, which until and unless not updated would not be able to identify new signatures. However, when you talk about AI, it would be learning, it would keep on learning from the data, from the existing data set, as well as it would be monitoring the network logs, it would be doing a continuous um, monitoring and analyzing of the network traffic. It would learn new patterns, and as it would learn new patterns, it would be able to identify the new emerging threats as well. Okay, so that's how adaptable AI methods can be, opposed to the traditional methods where adaptability would not be a feature. Then, when it comes to false positives, traditional threat detection methods would generate higher false positives compared to AI, because, again, as the reasons that we've seen in the previous points, AI would be using a much more sophisticated and a much more advanced pattern recognition methods, due to which false positives would be there, but it would be somewhat less than what you could see in a traditional threat detection scenario. Real life examples, I think all some of this we have already discussed in the previous use cases. Uh, so talk about the ones that are not discussed. Okay, so dark trace. So dark trace is a, uh tool that is for that tries to identify threats in real time by monitoring and analyzing the network traffic. So it's a particular tool for that. Then you have BioCatch. It's quite an interesting tool when you talk about BioCatch. BioCatch. So BioCatch, it tries to do threat detection based on behavior biometrics. So, what does it mean? When you say behavior biometrics, so what BioCatch would be doing, it would be capturing the finger strokes of users who are using their devices, who are whether it's a mobile, a laptop, or anything. Okay, so identifying patterns from the keystrokes, identifying patterns from how the mouse is being used, how you move your fingers over the mouse. So, based on that, they are trying to identify certain patterns, and then they use it for uh, identifying the normal behavior, and then from there, they will be identifying a deviation in the behavior, and pets. So that's a very unique use case, BioCatch. So silence, Great Paul, Tesla, I've already discussed. So even HSBC and Hikvision. So I think that brings us to Akamai. So now Akamai, it is again, it's a particular tool that is used for identifying the threats on different applications. But it's security. Okay. Uh, okay. Anyway, so these are all the use cases. I'm sorry, I'm not able to recollect the Akamai as of now. Very sorry. But yeah, these are some of the use cases or real life examples that are available for threat detection of how AI is being embedded into the threat detection. Okay. So okay, what are the other things that we can do apart from threat detection? Sorry. So once your anomalies are detected, what AI can do is you can automate how alerts are being generated, and you can use the particular uh, the results of detection algorithm, and then you can prioritize or make a changes in your different risk, and based on that you can generate alerts. Apart from that, contextual information can be provided by AI powered tools for for the threat intelligence. Contextual information in the sense contextual information in the sense uh, okay, if I just recall and go back to the point, I don't want to like pause it. So, anyways, organizations they can also tailor detection. Okay, yeah. So you can alter, you can customize how you want to do the detection, threat detection, based on your specific needs. So it's not that you have a fixed method and you just have a fixed uh, parameters by which you can identify the threats. As it's an AI or ML algorithm, you can just change the parameters, and based on all the predictions or based on all the detections that you are getting, you can always change, and then tailor tailor your model to identify the different threats. Okay. Then, yeah, obviously with AI, you can get up to date information on imaging threats, and uh, it, by using AI, you can also scale your solutions to large amount of data. Coming back to the contextual information, you can use AI for getting some deeper insights. Like, let's say you have a lot of unstructured data. For example, you have a lot of images that you have gathered. Now, from the images, if you want to do a meaningful insight, if you want to extract something meaningful, then for that you can use AI. Similarly, um, you can use the contextual information to interpret languages that is used by humans. For example, if you like collect a lot of posts and comments, okay, on social media, then a lot of data that is gathered from there, that would be that would be sentimental based, right? So from that you can identify certain patterns or identify certain things. Then also like if there is a chatbot, for instance, so based on all the questions that different users are asking to the chatbot, okay, when there are so many multiple users who are asking different questions to the chatbot, you get a collected data that has a lot of different context. So from that also you can identify certain patterns or any criteria that you want to identify. So these are some of the ways how you can integrate or you can use AI in different ways. Okay, then okay, some future trends of threat detection. So some of these are already available in certain tools, but these are ongoing and upcoming trends. So there's federated learning, self-supervised learning, graph-based anomaly detection, behavioral biometrics. One use case I already shared with you on that. Hybrid models, seamless integration, decentralized threat intelligence, edge AI, and autonomous cyber defense. So when you talk about federated learning, so federated learning means where you would be using local data for uh, the different machine learning or the AI algorithms. So what happens is that here the main focus is on maintaining the privacy of user. So instead of using a wide data set that could be available on a centralized server or across different domains, they prefer to use a local data set that helps to achieve certain kind of privacy for user. So that's what federated learning would mean. Self-supervised learning. So the GPTs that we see over here, that's somewhat related to the GPTs, where self-supervised learning methods in AI, they focus on the algorithms learning patterns from the data that they detect or that they analyze in real time. So they would be evolving the algorithm or the prediction methods by themselves based on all the current data that they are uh, gathering and analyzing in real time. So self-supervised learning talks about that. Graph-based anomaly detection is a process or is a trend where graphs would be used for performing certain kind of threat detection. Behavior biometrics, as I already said, they want to use the keystrokes, and I don't mean the keystrokes of the keylogger, but how you press the keys, okay, and how you use the mouse, okay, the gestures, the finger positions, and everything. Those are being detected, and based on that, there would be methods by which you would be trying to detect certain threats. Hybrid models. Hybrid models, they would be talking about integrating AI along with, let's say, threat detection into a field like IoT. Apart from that, uh, we would be combining blockchain with AI. Um, one of the trends you see in hybrid models is where they also want to include blockchain into AI and then use it, well, like come up with techniques that uses blockchain based AI to perform the threat detection. So that is one of the things that hybrid models talks about. Seamless integration. This is where we want to use AI integrated with the already existing tools that are already available. It could be Splunk, it could be some other tool as well. So that is what seamless integration talks about. Decentralized threat intelligence. So when you say decentralized threat intelligence, it's about localizing the threat intelligence instead of being dependent on a central server, okay, or a central repository. And then uh, edge AI. Okay, actually, Edge AI and decentralized threat intelligence would go hand to hand because it's quite similar. When you say uh, Edge AI, then again it's the same thing where the detection and everything that you want to do would be on the edge devices or on the localized devices rather than a centralized repository or a centralized server. And autonomous cyber defense is where we want to automate all the process and try to provide automated threats, automated alerts, and things like that. Okay, so yeah, that's all for what I wanted to share. Have any questions? Then surely you can ask. Thank you.
Uh, Jui, there are two questions. You can address those. We have
Okay.
posted on Q&A section. Yeah.
Okay. Just give me a moment to look into the question. How can we perform predictive threat modeling using AI-based devices like cameras and sensors? Uh, okay, so first of all, cameras and sensors are IoT devices. So see, what happens when you use the cameras and sensors? By default, when you're using the cameras and sensors, you are going to collect a lot of data because they would not be operating for 1 hour or 2 hours or something. They would be operating for a long time. So by most of cameras and sensors, they generate a large data. When you have a large data, okay, that data will have different kind of patterns or different kind of in-depth because uh, uh, as I said, the data would be very large. So the basic point of machine learning, where or the most basic way in which the machine learning algorithms or even predictive algorithms are used is that for first of all the machine learning model. For example, let's say you are using the KNN classifier, or you are using the naive Bayes method, or you are using the clustering algorithm. Okay, random forest or something. Okay, so what they do is if it's the machine learning model, it needs to learn. So how would it learn? It would need data by which it would be learning. So when you have this huge amount of data, that data you feed it to the model. That model will use that particular data, and after analyzing the entire data, it would be learning certain things, and then based on that, it would be doing the making certain decisions, which we term as prediction in our layman's term. Okay, so that is how it would be doing it. I hope that answers your question. Um, terrorism detection. Uh, terrorism detection. We are not talking about uh, terrorism detection uh, traditional way or uh, in the real life way, like we are not talking about Interpol or something. If that's what your question was, here we are talking about online threats that could come from these terrorist groups. Okay, so when you talk about cyber terrorism, it is first of all it is related to cyber terrorism. Okay, I think these two are the only questions. Yeah. So, first of all, this is related to cyber terrorism. So, what does cyber terrorism mean? Cyber terrorism would mean where these terrorist groups they are using the online media or the internet for spreading hatred or spreading fear. The main thing what they use, the factor that they use is fear, right? So they want to spread fear. They want to give threats, right? So many of them or their activities include using the internet mediums. So when you say terrorism detection, it means that whatever things they are trying to do in the cyber world, okay, it could be espionage, it could be information stealing, because as of now, one of the most important thing for any nation is the data, right? Whether it is India or any country, whatever advancement we're doing on the technology or on the any front, the data becomes very important. So terrorists, they are also looking after your data, how you can capture the data, what research they are doing, or what things are being done, so that they can use it in some of the other way to create a threat or something. Then many of them, they would be trying to go to the dark web for hiring youngsters or something. So there are things from very basic things, from very simple things, like just spreading some negative post on social media about uh, 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 certain race or certain religion or something, and doing drastic things. Okay, when you talk about terrorism, it could lead to anything. So when you talk about terrorism detection, it would mean that how we can use threat intelligence to identify as many as possible threats that cyber terrorism could give, and you try to avoid those threats. So I hope that answers your question.
Thank you so much for this session, Jui. There are no more questions, so we can
Okay.
proceed to wind up the session. It was really a wonderful session. Thank you.
Thank you. Thank you very much.